Let's now start to wrap our heads around the implementation. So let's talk about building an agent. We can outline the process of creating the agent as having a number of different distinct steps. Let's take these one by one, starting with the very familiar process of creating an Azure AI Foundry project. I think by this point, we don't need to be sold on the great benefits of using Azure AI Foundry projects. They provide a centralized workspace for our AI apps. We get access to a wide range of AI models, and of course, they facilitate collaboration. Next, we've got to choose and deploy an AI model. Again, we are familiar with the actual process of deploying models. However, here choosing the right model may be a little hard. You've got to align the model capabilities with your use case. Then we've got to make sure that the model we pick matches the tool calling support that we need. So the models need to support tool calling, and this is offered by GPT-4o, AI21's Jamba, and Cohere's Command R+. Then, of course, we've got to assess the deployment options, such as serverless, provisioned throughput, or managed compute, always keeping an eye on costs. And finally, keep reviewing model benchmarks and performance metrics. Here are some thoughts on choosing the right model. Remember that the biggest is not always the best. If we need reasoning and multimodal capabilities, then GPT-4o is a perfect choice. If we'd like cost-effective deployments, which still have strong performance, then the 5.4 Mini offers a good balance between performance and cost. These capabilities are comparable to larger models in some tasks, such as math and coding. If we want high-speed inference for real-time applications, then Mistral Small 3.1 is probably a safe bet. This is designed for fast inference and has very de-Diacing latency, so it's perfect for real-time apps such as chatbots and interactive systems. If multilingual support is a priority for us, then Cohere Command R+ is an excellent choice. This has been optimized for multilingual tasks. Then we've got to define instructions for our AI agent. Some quick thoughts on best practices for writing these instructions. The instructions need to clearly define the agent's role and objectives. They should provide explicit guidance on when to use tools. They need to establish constraints and safety measures, and this also includes specifying what information is inappropriate or out of scope. The instructions need to be written in a style and tone that is consistent over time. And finally, and perhaps most importantly, remember to keep iteratively refining the instructions based on user feedback and on the performance of the agent. Next, it's time for the exciting process of integrating the tools. These will actually take action. Remember that there are, broadly speaking, knowledge tools, action tools, and then third-party tools. Then it's time to test the agent. And this process is even more important with AI agents than with other types of software, just because of how they are going to perform actions autonomously. So we should make use of the agent playground for interactive testing. We should constantly be running the monitor agent to keep track of the outputs of our tools. The monitor agent can generate a run reports to capture the sequence of messages, tool invocations, and responses. We also ought to leverage the built-in evaluators, which we've already discussed. And lastly, do not neglect content safety measures. We need to test against potential misuse and harmful inputs. Azure AI Foundry includes content filtering and safety features to help with this. Once we are satisfied with the test results, it's time to deploy and access the agent from out in the wild. We begin by deploying our agent to the Azure AI Agent Service. This will expose an endpoint. This can be used to interact with the agent. And of course, we and Kirkbeck now integrate the agent into our applications. How exactly do we access the agent? Well, there are three familiar options. There is the Azure AI Foundry portal via the Agent Playground. Then we have the Azure AI Agents SDK. And finally, there are the trusty REST APIs. Use an agent. During this video, discover how to identify agent building blocks, threads, messages, and runs. Let's keep going with our exploration of agents. We are now going to talk about using an agent. In this context, it's helpful to think of three different found building blocks. There are threads, which are conversation sessions between an agent and a user. These store messages and automatically handle truncation to fit content into the model's context. So when we create a thread, we can append new messages to it as users respond. Then there are messages. These are the individual pieces of communication within a thread. These may be created either by the agent or the user, and they can include text as well as other files. Messages will be stored as a list within the thread. Finally, there are runs. A run involves invoking the agent on the thread, where the agent will process messages in the thread, and it might append new messages, that is, onto the end of the thread. The agent will use its configuration in the thread's messages to perform tasks by calling waddles. As part of a run, the agent will append messages to the thread. It might occur to you that these building blocks are identical to the building blocks of an assistant. However, remember that in this case, the runs might invoke tool invocations, which will have effects outside the context of the thread. That's the big difference between the runs on an agent and runs in the assistants. MS-Learn has an excellent diagrammatic representation of how agents, threads, and runs fit together. As always, let's break this down. You see here that we have a personal finance bot. We start out by giving it instructions. You are a personal finance SILIF. You pick any compatible model, and you decide that the tools that you need are file search, code interpreter, and function calling, maybe some others as well. Now, a user initiates a thread about retirement planning. The user's message here is, "How much should I contribute to my retirement account?" This gets sent to a run, and the agent here is the personal finance bot, and the thread is this retirement planning thread. The steps involved include using the code interpreter on some uploaded files containing the details of this particular user's financial history, and then crafting a message which gets sent back on the thread. So far, this might look a lot like the use of a simple chatbot, but remember that the tools might also do a lot more. For instance, they might use a third-party API in order to check the current value of the user's 401k. That's not something which a chatbot will be able to do.